you stop thinking of people as people and you start thinking of them as particles, actually what you see in mosh pits is this behavior that is common across systems of fluids, essentially. And each person effectively is like a particle, right? They're propelled, they're constantly colliding, and they're reacting to what's going on around them locally, not the whole global system. So these physicists, what they did is they made this mathematical model, this computer simulation. I mean, adorably good sense of humour here. They called it the Mobile Active Simulated Humanoids model, otherwise known as MASHers. Cute. And there are two different tendencies that people have when they're in this sort of crowd situation. Either we tend to copy what people are doing around us, flocking behavior, which is what you get when you see big flocks of birds, where they're sort of copying the average speed and direction of their neighbours. But then you have sort of more random movement, unpredictable movement when we're acting as an individual, say somebody spots a friend or whatever it might be. And what they found is that actually these mosh pits, they do have this gas-like state. They essentially form the same patterns that you would see if you were looking at a box of atoms, right? This sort of disordered gas. People are sort of pinging around from each other in this disordered way. But then when you get more people going in, people organize into this vortex-like state, this sort of circular motion that you see precisely as you do in fluids, where people are sort of rotating with the audience. This emergent property. Nobody ever says like, okay, off you go, start rotating in this direction.
These are people with their own personal wills, and they haven't organized any of these patterns.
That is just something that happens when you stop behaving like people and start behaving like particles. If you stop thinking of people as people and you start thinking of them as particles, actually what you see in mosh pits is this behavior that is common across systems of fluids, essentially.